standard RAG has one reflex. Embed everything, embed the query, grab the nearest chunks. Fast, scalable, and completely flat. Flat means it throws away the document structure. It retrieves by surface similarity, which can miss the right passage while grabbing plausible-looking neighbors. There's another way, and it's almost the opposite philosophy. It's called PageIndex, and it uses no embeddings at all. Instead, it preprocesses a document into a tree, which is really just its table of contents made navigable. Each node carries a title, a short summary, and the page range where its content lives. No vectors, no index, just structure. At query time, the model is handed that tree and it navigates exactly like a human flipping to a chapter. At each level, it reasons. Which branch is most relevant? It descends. It reasons again, down to the right section. Then it reads only that section's pages and answers. Route to financials to risk factors, a reasoned path. Here's the contrast that is the whole lesson. Vector search finds the right section, plus a couple of unrelated chunks. Why the junk? Because cosine similarity is blind to where things sit in a document. It only knows what looks alike. PageIndex doesn't just find the section, it can explain why it went there. Risk factors live under financials, so I went under financials. And that explanation matters more than it sounds. With a vector hit, you get a chunk and a score and no idea why. With a reasoned path, you get an audit trail you can actually trust. But let's be honest, because this is not magic and it is not strictly better, it just trades one set of costs for another. A vector lookup is a single approximate nearest neighbor query, milliseconds, and it scales to millions of chunks cheaply. PageIndex spends an LLM call at every hop down the tree, so it's slower and it costs more per query, which tells you exactly where each one wins. Reach for a vector database when you have a huge, messy corpus and need fast recall across millions of chunks. Reach for PageIndex when you have a small number of well-structured documents, a contract, a 10K, a manual, especially when the question needs the model to reason about where the answer lies, not just what looks similar. And here's the lovely part. They aren't rivals. They compose beautifully. Use vector search to shortlist the right handful of documents, then let PageIndex navigate within the chosen one. Fast funnel, careful finish. Why does this even work now? Two things had to arrive. Models got good enough at multi-step reasoning to walk a tree reliably. And context windows got long enough that a node's summaries and the chosen section fit comfortably in the prompt. It's part of a bigger shift, using the model's reasoning at retrieval time instead of treating retrieval as pure similarity lookup. So remember the picture. Flat search asks what looks similar. Tree navigation asks where would a careful reader actually look. Sometimes that second question is the whole game.